Thermal expansion. Most materials expand on heating while contract on cooling. Displayed here are the examples of thermal expansion. A completely filled and tightly capped bottle of water cracks when it is heated due to the expansion of water molecules. Lid of a metal jar can be removed by dipping the jar in hot water. This is because the metal lid expands due to the absorption of heat. Did you know that the wing panels of high-speed aircraft when on ground fit together so loosely that fuel may leak out of the wings? But once it starts flying with a speed equal to 3 times the speed of sound, the panels expand to make a perfect fit. The expansion of solids is due to change in interatomic separation. Let us try to understand thermal expansion qualitatively on the basis of molecular theory. Let us visualize the forces between the neighboring atoms in a solid by imagining them to be connected by springs that are easier to stretch than to compress. Each atom vibrates about its equilibrium position. When the temperature increases, the energy and amplitude of the vibration also increase. The interatomic spring forces are not symmetric about the equilibrium position. They usually behave like a spring that is easier to stretch than to compress. As a result, when the amplitude of vibration increases, the average distance between molecules also increases. As the atoms get farther apart, their dimension increases. The thermal expansion of solids is of 3 types, namely linear expansion, superficial expansion, and cubical expansion. Linear expansion. If the change is only in the length of the object, then the expansion is called linear expansion. Let L be the length of a rod at some initial temperature T. When the temperature changes by delta T, the length changes by delta L. It is found that if the change in temperature is not so large, say less than 100 degrees Celsius or so, then delta L is directly proportional to delta T and its original length L. Therefore, delta L is equal to alpha into L into delta T, where alpha is the constant of proportionality called the coefficient of linear expansion. The unit of alpha is per degree Celsius or per Kelvin. Think it over. Superficial expansion. The change in area of a solid is called superficial expansion. If A is the initial surface area of a solid and delta A is the increase in surface area due to a temperature change delta T, then increase in the surface area is directly proportional to the original area and increase in temperature. Delta A is directly proportional to A into delta T. Delta A is equal to beta into A into delta T, where beta is the constant of proportionality called the coefficient of superficial expansion. The unit of beta is per degree Celsius or per Kelvin. Cubical expansion. The expansion in the volume of a solid is called cubical expansion. Let V be the initial volume of a solid and delta V its expansion due to a temperature change delta T. Then the increase in volume delta V is directly proportional to V into delta T. Therefore, delta V is equal to gamma into V into delta T, where gamma is called the coefficient of cubical expansion. The unit of coefficient of cubical expansion is per degree Celsius or per Kelvin. Gases and liquids also expand on heating like solids, but water behaves in a different way. Let us now see what happens when water is heated. Thermal expansion of water. When water at 0 degrees Celsius is heated, it contracts till 4 degrees Celsius instead of expanding, and behaves like any other liquid above 4 degrees Celsius. This behavior of water is referred to as anomalous expansion of water. Anomalous means irregular or deviant feature. Natural consequence of anomalous expansion of water. When the water on the surface of a water body cools down to 4 degrees Celsius, its density increases, and hence it sinks. The warmer layer of water from the bottom rises to the surface. This layer cools to 0 degrees Celsius, thus forming a layer of ice. The dense layer of water at 4 degrees Celsius remains in the liquid state, as the ice formed on the surface is a bad conductor of heat and provides a suitable condition for the survival of fish and other aquatic animals.